In this video, we will look at how law curves can be used to create relationships between variables in your model. When writing your code scripts, you may want to generate a model where one variable is dependent on another variable. In this example, we have created a conceptual diagram of a section through a set of floor plates. The floor plates vary in width as the floor number increases. We can consider that there are two variables: the floor number variable and the width variable. The floor number varies between 0 and 20. The width varies between 18 meters and 30 meters. When we are generating such a model, it would be useful to have a local function to calculate the width, given the floor number. Such a function might be called getWidth. You might create a for-each loop that generates floors, from 0 to 20. Each time around the loop, the getWidth function would be called, and the floor plates with the right width would be generated. If the relationship between the floor number and the width is a mathematical one, then a law curve could be used. In this case, we can see that the relationship is based on a sine curve. The input to the law curve is usually defined along the horizontal axis and is labeled t. The output of the law curve is usually defined along the vertical axis and is labeled rt. But the sine curve is infinitely long. The first thing is to understand the domain and range of the function you are working with. The input on the x-axis is called the domain. The output on the y-axis is called the range. The domain is the independent variable and range is the dependent variable. The values along the horizontal axis are angles in radians. And the values along the vertical axis are between -1 and 1. In this case, the building being generated has two humps along its height. So the domain of the sine curve needs to be set to include two humps. The domain can be from 0 to 3 pi. The range will be from -1 to 1. However, the domain and range of the law curve do not match the values required in the model. So to be able to use the sine curve to generate the floors, you will first need to do some number manipulation. The floor number has a domain that varies from 0 to 20. It needs to be mapped to the domain of the law curve, which in this case is 0 to 3 pi. The range of the law curve varies from -1 to 1. It needs to be mapped to the width range, which varies from 18 meters to 30 meters. A mapping function can be used in order to map numbers between domains or ranges. Such mapping functions are straightforward to implement, but are available in most programming languages. So we won't look at the internal implementation. Instead, we will just assume that such a function is available. We will use a function called remap. To see how the remap function works, let's look at an example. The function has three parameters. The first is the value that you want to map. The second is the source domain to map from. The third is the target domain to map to. In the example code, the value to be mapped is 5. This value is 25% of the way along the source domain. So the result will also be 25% of the way along the target domain. 25% of 3 pi is 0.75 pi. Maybe pause the video and check that you understand the mapping. The remap function can be used to perform both mappings. You can map from the floor number domain to the law curve domain. And you can map from the law curve range to the width range. Between these two mappings, you can apply the law curve. Overall, it forms a three-step process. Map domains, apply law curve, and map ranges. Here is a diagram of the process. The flow of the function calls can be traced, starting with the floor number and ending with the width. In code, it would look something like this. Two functions are defined: the law curve function and the get width function. The law curve function is actually trivial, so in this case the sine curve could have been used directly. But we include it here for clarity. The get width function first defines the two ranges and the two domains. Then it performs the three steps: map domains, apply law curve, and map ranges. The get width function can then be used in the main code to generate the floors. For each floor, the function will be called, and the width will be calculated. Law curves do not have to be sine curves. They can be any combination of mathematical functions. Here are some examples. There are many websites that allow you to experiment with equations and visualize the result. The law curve domain and range can be any valid domain or range that the function actually covers. In this example, the domain is selected for only a small part of the curve. The range can then be calculated based on the domain. Finally, the mapping between domain and ranges can be any number sequence. In this example, the domain of variable 1 is reversed. It starts at 200 and decreases to 100. And the range for variable 2 start at -20 and increases to -10.